Hey everybody, I hope the last vector video that I'm going to do here. I want to talk about a unit vector, and this is a very special unit vector. We've already talked about the I unit vector, I hat, that points in the x direction, has a length of 1, not 1 anything, no units there, right? Even though it's a unit vector, right? It's kind of like in trigonometry, again, the unit circle has a length of, or radius of 1. And so the j hat, and then of course k hat came out of the board. So what we've got here is I've got a vector q, and it's a position vector, it's a distance vector, right? So it's got a length of 50, it's the green vector you'll see here. It's got a length of 50 and it's pointing in this direction. And that would be, what, 53.1 degrees. Right, so I could write q as 50 centimeters at an angle of 53.1 degrees. It's a 3, 4, 5 triangle. So it's got an x component of 30 centimeters, and so the x component is 30 centimeters, so the vector is 30 centimeters in the I hat direction, plus 40 centimeters in the y direction, so 40 centimeters in the j hat direction. All right, so what I'm looking for when I'm talking about this unit vector now, I want a vector, I'm going to call it q hat. The hat is indicating that this vector has a length of 1. How do I do that then? So it's pretty straightforward. What I'm going to do is I'm going to take the actual vector that I have. Well, let me write it this way. Let me do it symbolically first. So I'm going to write q vector. So I'm going to take the q vector and I'm going to divide by the magnitude of the q vector. Because if I do that, then I'll get a vector with a length of 1. All right, and so this will be 30 centimeters in the I hat direction, plus 40 centimeters in the j hat direction. And then I'm going to divide by the length of that, which is the square root of 30 squared plus 40 squared, but it's a 3, 4, 5 triangle, so that's 50 centimeters. So 50 centimeters, right? That's the length of that vector. So notice what happens here. The centimeters in the denominator cancel with the centimeters in the numerator. So the centimeters are going to go away. And the zeros will also go away. So let me get those out. Not that that's always going to happen, but the units, in this case the length units, could be speed units or force units, whatever else there is that's a vector quantity. Those units will all go away. And so what I'm going to end up with for q hat, I'm going to end up with 0.6, that's 3 over 5, that's 0.6 in the I hat direction, plus 0.8 in the j hat direction. And if you do 0.6 squared plus 0.8 squared, add them together, square root, you're going to get 1. And so this has a length of 1. Notice there's no centimeters, those went away. Right there, so there's no dimension to this vector, but it is a vector without dimension, but it has a length of 1. So that is a unit vector. And this is going to hold true whether or not we're in 2 dimensions. I show it to you here in 2 dimensions, but in 3 dimensions it's the same thing. The magnitude of q, if this was 3 dimensions, I'll just write this in general, the magnitude in 3 dimensions would be q sub x squared, right, that's a cube, plus q sub y squared, plus q sub z squared, all under the radical. So you just take the x component, square it, the y component, square it, and the z component, and you square it. And that will give you the magnitude of that vector. All right, so we're going to do that a lot in the future of statics. So we really want to get a good firm grasp of a unit vector in that dimension. Because what's going to happen is I'm going to take something like a string, and I'm going to have that piece of string, it's going to have a length of 30 centimeters and 40 centimeters in the y, 30 in the x, 40 in the y. And I'm going to pull on it, which means there's going to be a tension. And that tension is going to have a direction and a magnitude. And what I need is that direction. Well, the direction will be in the q hat direction. It'll be in the same direction as the string itself. And we'll see a lot of examples of that coming up. All right? All right, if you have any questions on the unit vector, please leave them in the comments below. Thank you.